All right, we're going to start by trying to calculate the total amount of steps per turn of these for this or lead screw, which is in here. I just assume that whatever mill you're using, it's an unknown. In this case, I believe it's a SAE, but I'm not sure. So I'm just going to start with this ruler, and I'm going to place it here, and I'm just going to do it the simple way. Now, over 300 millimeters. Now, if you have some turns and you're trying to measure 25 millimeters or 25.4, that might be a little difficult. Now, if you're trying to get accurate and verify that you're not off by 0.4 or whatever, you need to do multiples of it. So I'm actually going to spin this screw enough times to go all the way through the 300, and then that's essentially, if it was inches, it's enough times to where it'll be able to be calculated and whatever. And I'm just going to count based on the turns of this knob here, which is on the end. So I can just guess or count how many times it goes and how far I go. Because really what I need to know to figure out steps per millimeter is how many millimeters per turn this screw moves, because it's a linear motion, but it's going to be converted to rotary on this, and it's 1.8 degrees per step. So if you're trying to calculate steps, you need to know turns first, because there's 200 steps per rotation. So if you can do that, it's pretty easy. All right, after 60 turns, as you can see, it brought us just past the end there, which tells me this is probably a SAE screw, not a metric screw. So let's go back a little bit. It's, let's see, just about one turn back is where it's at. So 59 turns for 300 millimeters. That sounds like an SAE number to me. So I'm gonna do the math on that and we'll do the calculations.
Okay, now that we've done the measurements and calculated the turns, we know this unknown anti-backlash lead screw, I believe it's a Thompson screw if I remember right, 5 turns per inch, 200 steps per revolution, 25.4 millimeters per 1,000 full steps. That means there's 0.0254 millimeters for a full step. If you're using 64 times microstepping like I am, initially, I'm going to be interpolating out to 256 through the drivers. It's kind of a sketchy thing to do sometimes because there is a recommendation or a note in the data sheet about using the interpolation, about potentially having miscalculations on full steps and things like that, or on steps. It's a note in there that can be read about. I'll bring that up later. But with the 64 times initial microstepping I'm using, it's this number per millimeters per step. Now for one step, it's this number. Divide that by one step, gives you the steps per millimeter. Now this number directly here is the number you would put into your config in Smoothieware. So we will have this and we're ready to start that part.